Hey everybody, welcome to Mac's Tutorials. This is Mac right here, and we're going to work about systems of equations solving by substitution. I did a video earlier where we did these by graphing, but sometimes these don't fall nicely on the graph, which actually happened to a couple problems in those videos. And so when that happens, you can't use graphing. You're going to have to use a different method. And there are two that will give you an exact number, and that's solving by substitution and solving by elimination. Solving by substitution works really well when you have at least one of the equations, say, a y equals or an x equals. Okay, so when you have it set up like that, I'll show you what to do. Before I do, I just want to remind you that there's a lot of this algebra on maxtutorials.com. If you haven't visited this yet, there's a lot of good information, and if you could like and subscribe this video, it'd really help me out. Okay, so on this one I see two equations, and I see right here the y equals x plus 2. So when I see y equals x plus 2, let me ask you this: what if that said just y equals 2? What would you do? You'd probably take that y equals 2 and you just plug in 2 for y, wouldn't you? Okay, so but this doesn't say, this is x plus 2. So what are we going to do? I'm just going to write this equation right here, this one, 2x plus. Now I'm not going to write y, because what does y equal? Y equals x plus 2. Best to write it in parentheses. In this case, the parentheses aren't going to matter, but get used to doing that, because depending on what's in front or behind it, the parentheses might matter a lot. And that's going to equal 11. Well, the parentheses don't matter in this one, but I do see that I have like terms. 2x plus 1x is 3x plus 2 equals 11. And as I go minus 2, and I'm just going to do a normal solving. I do this in chapter 2 of Mac's tutorial, so if I'm going a little too quick, go back there. We want to make sure that you can solve these equations in a snap. Okay, so I know now that my x equals 3, which is cool. You're only halfway done, though. You want to go back and plug it in, and it's always best to plug it in the one that had the y equals or the x equals. Just plug it in there, and you're going to get y equals, well, don't put in x. What are you going to put in? You're going to put in 3, because that's what x is, plus 2, and my y is going to equal 5. Now I'm done. My x is 3, my y is 5. So you can see here, you don't have to worry about, well, where exactly did those points cross on a graph? Is that really on, where they cross on the grid or not? Now you're going to get a number, and it's going to work out great. Let's just go down here, down the column. Number 2, I see a y equals something right here, so I'm going to use that one. And I'm going to take 2x minus 1, and I'm going to plug it in where the y is. Okay, so here, instead of x plus y equals 8, I'm going to write y x plus, and what is y? Y is 2x minus 1. Okay, and that's going to equal 8. X plus 2x is 3x, minus 1 equals 8, add 1, add 1, 3x equals 9, boom 3, x equals 3. All right, now if I go back in, let me get some of these lines out so they don't look so confusing. I'm going to take this 3 and I'm going to plug it right into there. Okay, and so instead of writing y equals 2x minus 1, I'm going to write y equals 2. What is x? X is 3 minus 1. Y equals 6 minus 1. Y equals 5. There we go. Number 3. Here we go. Y equals negative x plus 7. So what I'm going to do is I'm going to take, what does y equal? I'm just going to plug it right into the y here. So now I'm going to get x plus 2. Remember, I said always do this in a parenthesis, and in this case, the parenthesis does matter quite a bit. Okay, so if you don't do that, you may do the 2 with the x, but you don't see that as that 2 also has to go to the 7. I have to distribute it to both. And if you don't write the parenthesis, you're not going to see that. So that's one thing I'll see students have trouble with. And I'm going to get x. What is positive 2 times negative x? It's negative 2x. What's 2 times positive 7? That's a plus 14, and that equals 12. Now let's combine our like terms. X minus 2x is just a negative x. Plus 14 equals 12. I'm going to minus 14 from both sides. Boom, die. Negative x equals negative 2, or x equals 2. Now if I go and plug that back in there, y equals negative 2 plus 7, y equals 5. And so the good thing about substitution is you have to do a lot of work to get the first one, but then you usually don't have to do a lot of work to get the second one. Let me zoom in, and I think I can save a little bit of space here. Now, if you really wanted to, you don't have to, and I'm not going to, you could go minus x, and you would get y equals negative x plus 12, and then you could take that and you could plug it in, there if you want. I don't think that's the easier way to do that, but I'm just saying theoretically you could. Here it's already set up as a y equals. So let's just take what y equals and let's just plug them in the y, okay? So x plus 4x minus 3 equals 12. Now here the parenthesis doesn't matter because the only thing in front of the parenthesis is a plus sign. But what if it was a negative sign? Then you'd have to go to both the 4x and the 3. And so that's why we want to do the parentheses. But here we're just going to collect like terms, okay, which is going to give me a 5x minus 3 equals 12. And when I add 3 to both sides, I'm going to get a 5x equals 15. I'm going to divide both by 5, and I'm going to get x equals 3. And then once I plug that in, I'm just going to plug in right there. 3 plus y equals 12. And once I subtract 3 from both sides, I just get a y equals 9. Now, you can always plug them back in. I'm not going to take the time to do it, but you can see that 3 plus 9 is going to be 12. And if you plug it in here, let's just do it in our heads real quick. 12 minus 3 is 9. Oh, there's 9, okay? So that's one way to just make sure then you got the right answer. Hey, I'm going to give you a trick right here, but don't tell anybody, okay? It's just going to be our secret. Don't let anybody else know this. It's a longer way to do it, but what if this were multiple choice, okay? And they gave you multiple choice answers and you totally just blanked and you forgot what to do. You can just take the answers and plug them in and see if they're right. Okay, so that's a kind of a backwards little cheat. It's not a cheat because you got to do math and, to figure it out, and you're, using intelligence to make that happen. It's not like you wrote it on the back of your hand, but that is like a little hack you can do if you totally go brain dead. But let's not go brain dead because it still is easier to do this, because what if the answer is D? Then you just had to do, 6 math problems before you can get to the answer, or 7 or 8. Here we go. Still better to do it right the first time. Okay, I'm going to plug that in for y. 2x equals, and instead of y, I'm going to write x minus 4. I'm sorry, I shouldn't have wrote equals. If I look here, it's 2x plus x minus 4 equals 8. Parenthesis meant nothing in this case. 3x minus 4 equals 8. Plus 4, boom, die. 3x equals 12, divide each side by 3, and our x is going to equal 4. Now I'm going to go back in and plug it in here. Boom, boom, boom. Y equals 4 minus 4, y equals 0, and we're done. Here we go, moving forward. Now we have a y equals negative x plus 5, so I'm going to take all this and I'm going to plug it in where the y is. Using those circles and arrows actually does help, so try getting used to doing that. I think it'll help you. Negative x plus 5, and that equals 9. It's just a plus sign in front of the parentheses, so that means nothing, so I can just go straight to combining, and I'm going to go 2x plus 5 equals 9. Subtract 5, boom, die. 2x equals 4, divide everybody by 2, x equals 2, boom. Okay? Then I'm going to take that, and I'm going to plug it in, boom, 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 boom. And when I do that, I'm going to get y equals negative 2 plus 5, y equals 3. So my answer is 2 and 3. Let's go on to number 7. Here, my y equals that, so I'm going to plug that into the y. Ooh, I see that negative sign. That's going to come in into play here. I'm writing this one right here. So what I want to write is 2x minus, and remember, always substitute in with parentheses, and instead of y, I'm going to write in what y is, which is 3x plus 2. And that's going to equal negative 7. Now, this parentheses mattered because when you have a negative in front of a parentheses, and we did this when we talked about adding and subtracting like terms, combining polynomials. That's in Unit 1 on maxtutorials.com. At the very end of Unit 1, we talk about subtracting polynomials. And when you have a negative in front of a parenthesis, that's like negative 1 times both of them. You got to do both. So once I do that, I'm going to get 2x minus 3x, and here's the part people miss, minus 2. equals negative 7. That's going to give me a negative x minus 2 equals negative 7. Once I add 2 to both sides, I'm going to get negative x equals negative 5, or x equals a positive 5. Now I go and plug them in. I can plug them into either one. I'm going to go and plug it right into there. And I'm going to write y equals 3 parentheses 5 plus 2. That means y equals 15 plus 2. Y equals 17, okay, which would look really ugly on some of those smaller graphs. So that's why it's really good that we have that. Oh my goodness, I put 10 problems in here. How at a meanie. Okay, so now here, oh, fractions, that's a little scary. Y equals that. So we're going to plug it in to there. All right, so we're going to get x minus parenthesis 1/2 x plus 1 equals 5. Now I'm going to distribute that negative to both, and I'm going to get x minus 1/2 x minus 1 equals 5. When I combine my like terms here, I'm going to get, let's just write 1/2 x. Okay, what's 1 minus a half? It's a half, okay? So minus 1 equals 5. If I add 1 to both sides, boom, die. 1/2 x equals 6. I solve that by multiplying each side by 2, and I'm going to get x equals 12. Boom. All right. So now if I go back into here, boom, boom, we get 12 minus y equals 5. Subtract 12 from each side, boom, die. Negative y equals negative 7, or y equals 7. There we go. Going on to number 9, y equals blah. So I'm going to take blah, and I'm going to plug it in for y. X equals, what is y? Sorry, it's not equals, it's x plus. And now I'm going to put in y, but y equals negative 2x plus 6, and all of that is going to equal 2. Now let's combine our like terms, and I'm going to get negative x plus 6 equals 2. And if I subtract 6 from both sides, I'm going to get negative x equals negative 4, or x equals positive 4, by dividing both by a negative 1. Now, if I take that, I'm going to go whoop, straight up to there. I'm going to get 4 plus y equals 2. Once I subtract 4 from both sides, I'm going to get y equals negative 2. Okay? And there's my answer, and I got one more. This is set up perfectly, y equals x plus 5. So there's my blah. I'm going to plug it into there. And remember what I said, always plug in with the parentheses, because you never know when that's going to be important, like now. That negative goes to both. So we're going to get 3x minus 5 equals 7. Boink. 2x minus 5 equals 7. Boom, 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 and die. 2x equals 12. Boom, 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 boom. X equals 6. Then we're going to go plug it in. Y equals 6 plus 5. Y equals 11. All right, so there's 10 problems on substitution, and I got more. Now, the reason why you might use substitution here is because one of them says y equals or x equals. Sometimes they don't, and you have to move them around to make it work. For those, I would use solving by elimination. However, it's very possible you're going to get test questions that are going to look like that, and they're going to say solve by substitution, and your teacher wants to see you do it by substitution. Well, that's okay, because I got a version B, which will show you how to do it, and that's on the next video. So why don't you work some of those out, keep this going, and we'll see you on the next one. Good job, guys.